Children, what is acceleration? A change in velocity is called acceleration. Now, let us derive a formula for acceleration. The equation for acceleration. Acceleration equals change in velocity divided by time. This equation is written as A equals v minus u divided by t, where A equals acceleration, v equals final velocity, the one it ended up with, u equals initial velocity, the one it started with, and t equals time. Children, this equation is a very important equation. Now children, what is the unit of acceleration? The unit of acceleration is called meter per second squared. Now children, what is negative acceleration? When an object is speeding up, the acceleration is in the same direction as the velocity. Thus, this object has a positive acceleration. If an object gets slower, it will have a negative acceleration. This is sometimes called deceleration, but the term negative acceleration is more preferred. Let us now look at one example. Speed is a scalar quantity, but velocity is a vector that specifies both direction and magnitude. The speed is the magnitude of the velocity. For example, a car has a velocity of 40 miles per hour east. It has a speed of 40 miles per hour. Now children, let us try to identify whether the following is a scalar or a vector. An athlete was running 10 miles an hour towards the end zone. Can you identify whether this is a vector or a scalar? This is a vector because it represents magnitude at 10 miles per hour and a direction towards the end zone. This vector represents the velocity of the athlete. The volume of that box at the west side of the building is 14 cubic feet. Can you identify whether this is a vector or a scalar? Children, this is actually a scalar. It might be a bit tricky as it gives the location of the box as the west side of the building. But this has nothing to do with the direction of the volume, which has a magnitude of 14 cubic feet. Another example. The temperature of the room was 15 degrees Celsius. Can you identify whether this is a vector or a scalar? This is a scalar. There is no direction in temperature. Another example. The car accelerated at a rate of 4 meters per second squared. Is this a vector or a scalar quantity? This is a vector as it has both direction and magnitude. We also know that acceleration is a vector quantity. Before we can talk about acceleration, we need to understand velocity more deeply. The rate and direction of the change in the position of an object is acceleration. Velocity is a vector quantity, which means it has both magnitude and direction. If I were to be traveling in my car at 30 kilometers per hour to the north, the magnitude of my velocity or speed would be 30 kilometers per hour and my direction would be north. If I changed my speed or if I changed my direction as shown in the diagram, then I would experience a change in my velocity. This is where acceleration comes into play. Acceleration, also vector quantity, is the rate at which an object changes its velocity. The most obvious way that I could accelerate would be to change my velocity from say 0 to 40 kilometers per hour. However, I would also experience acceleration if I changed direction without changing my velocity, like driving around a bend in the road at a constant 30 miles per hour. In a large bend, where my direction was changing slowly, I would experience a lower acceleration than if I were to take a sharp turn, since my direction would change more rapidly. We can feel the difference in acceleration when we go around a car in a corner as a sensation that we are being pulled or pushed to one side of the other. Let us now look at few examples of acceleration. Consider a person riding a bike. Let's say that he starts out from rest and reaches a velocity of 10 meters per second by 1 second, 15 meters per second by 2 seconds, and 18 meters per second after 3 seconds. We know that the bike accelerated for the entire 3 seconds since the velocity kept increasing. But was the acceleration the same for each time period? We need to use the change in velocity over each period of time to calculate the average acceleration. As human beings, we are all caught up in a fascinating web of motion around us. We see people walking, animals running, vehicles moving on the land. We also see the kite and the birds and the aeroplanes flying in the sky. We also see that the boats and ship move on the water of the rivers and the seas, as shown in the diagram below. The sun daily appears to rise in the east and set in the west. The moon and planets also move around. We can, therefore, consider ourselves as being caught in a web of motion all around us.